Okay, here we are on number 2, and number 2 looks hauntingly similar to number 1. In fact, the only difference between number 2 and number 1 is the order of integration. So here we're integrating with respect to y first, then respect to x. The integrand's the same and the limits on both are the same, and so we would expect to get the same answer. At least that's what we've been led to believe. So let's go ahead and start integrating. We're going to start with the innermost integral first, the integral from 0 to 1, 2 times the quantity x minus y over x plus y cubed. Now I'm integrating this with respect to y. Y is the variable of integration. So I'm going to make the same substitution I did before. The du now is equal to dy. I'm going to change the limits as I did before. When y equals 0, u equals x. When y equals 1, u equals 1 plus x. And I'm going to have to solve this equation for y just as I solved it for x before. U equals x plus y is going to give me y equals u minus x. So when I go to transform this into an integral involving u's and x's, what do I get? I'm integrating from x to x plus 1. In the numerator I have 2 times the quantity x minus y. Y is u minus x, so when I simplify x minus the quantity, u minus x, I'm going to get 2x minus u over u cubed du. This integral is going to be evaluated similarly to the one we had before. So here's the integral, and as before we're going to break this up. The integral x to x plus 1 of, I'm going to have 4x over u cubed minus 2u over u cubed, which is going to give me 2 over u squared du. And now these are two Calc 1 integrals. U to the minus third integrates to u to the minus 2 over negative 2. So this is going to be negative 2x over u squared plus 2 over u, evaluated from u equal x to u equal x plus 1. And so I'm going to get negative 2x over x plus 1 plus 2 over x plus 1, negative 2x over x plus 1 quantity squared plus 2 over x plus 1 minus, substitute in u equals x, negative 2x over x squared plus 2 over x. So look what happens, just as before. I get a negative 2 over x and a plus 2 over x. That thing zeroes out. We're going to get ourselves a common denominator here. X plus 1 quantity squared. I'd have negative 2x plus 2 times x plus 1. The same kind of thing happens before. I'm going to be left with positive 2 over x plus 1 squared. And now I need to integrate this from x equals 0 to 1. So to finish off the problem then, here I am integrating this, and once again it's a Calc 1. So I'm going to get negative 2 over x plus 1, evaluated from x equals 0 to x equals 1, negative 2 over 2 minus negative 2 over 1. So to your surprise and or delight, well, probably not delight, maybe to your horror, I don't get negative 1, I get 1. And you might be wondering, well, what the heck's going on? I thought we could switch the order of integration with complete abandonment and recklessness. Well, here's the problem, and I'm not going to move to number 3, because number 3 says what gives. Well, what's going on with this? Look at this integrand. In order to switch the interval or the order of integration, in fact, even to evaluate the double integral as an iterated integral, we need to have the integrand be continuous. What's wrong with this integrand? Well, we're integrating over a square. So if we look in the xy plane, we're integrating over the square 0, 1 to 0, 1. Now let's look at that denominator. We're going to have trouble on that denominator when x plus y equals 0, or in other words, when y equals negative x. And look where y equals negative x lives. It lives mostly in the second and fourth quadrants, but guess what? It just happens to go through what point? It goes to the point 0, 0, and the point 0, 0 is on that square. So this integrand is perfectly fine everywhere except 0, 0. And that's just enough to screw this thing up so that the iterated integrals don't equal each other when you switch the order. So what's the lesson here? We need a continuous integrand to make this work out. That'll do it for quiz 12.